The rise of artificial intelligence. Imagine this. You wake up one morning, and the world is completely different. There are no sirens, no dramatic news headlines, no declaration of war, or a meteor falling from the sky, just silence. But in that silence, everything has changed. Your phone unlocks by recognizing your face. Your refrigerator orders milk on its own. Your music playlist knows your mood before even you do. And across the globe, decisions are being made, not by humans, but by something else. Invisible minds, digital brains, artificial intelligence. But how did we get here? How did we go from stone tools to digital gods? This chapter isn't about the future. It's about a hidden revolution that already happened. While most of us were looking the other way, Section 1. The first dream of intelligence. To understand artificial intelligence, we must first understand a very human desire, the need to create. For as long as humans have existed, we've been obsessed with the idea of life beyond ourselves. In ancient myths, people imagined statues coming to life. The Greeks spoke of Talos, a bronze giant that protected the island of Crete. In Jewish folklore, there was the golem, a clay creature brought to life by mystic rituals to serve its creator. Even Mary Shelley's Frankenstein, written in 1818, reflected this longing and fear of man-made consciousness. The idea was always the same. What if we could build life? But for most of history, these stories were fantasy. We had no electricity, no algorithms, no silicon chips, only imagination. That changed in the 20th century. Section 2. The machine age begins by the 1930s and 40s. Science and war accelerated the invention of computation. Mathematicians like Alan Turing were not only inventing early computers, they were inventing ideas. In 1950, Turing wrote a groundbreaking paper titled Computing Machinery and Intelligence. There, he posed a simple but mind-bending question. Can machines think? Rather than argue in circles about what thinking meant, he proposed something practical. And that human couldn't tell they were speaking to a machine, then didn't that mean it was intelligent? If a machine could carry on a conversation with a human through text, this became known as the Turing test, and to this day, it's still a benchmark for artificial intelligence. Turing's paper was dismissed by some as pure speculation, but for a small group of scientists, it was a rallying cry. The seeds of AI were planted. Section 3. The birth of a field fast. Forward to 1956. A group of scientists met at Dartmouth College for a workshop. They had a bold idea: to formalize a new field called artificial intelligence. This wasn't just programming. This wasn't engineering. This was about replicating the mind. The attendees included names that would become legends: John McCarthy, Marvin Minsky, Claude Shannon, Alan Newell, and Herbert Simon. They predicted that within a generation, machines would be as smart as humans. They were wrong. The computers of the 50s and 60s were laughably primitive by today's standards. A pocket calculator today is more powerful than the most advanced machines they had. But the optimism was powerful. These early AI programs could solve puzzles, play checkers, and even prove mathematical theorems. It was enough to get attention and funding. The world watched. Section 4. The first AI winter then. Reality hit. It turned out that building intelligence was a lot harder than anyone expected. Machines could follow instructions, but they couldn't understand. They couldn't deal with ambiguity. They couldn't learn. They couldn't generalize outside of what they were specifically programmed to do. By the mid-1970s, the hype faded. Governments pulled funding, media lost interest. This period became known as the AI winter. The first of several was a harsh lesson. Real intelligence was messy, full of contradiction and nuance. It wasn't just logic. It was emotion, intuition, memory, experience. Researchers didn't give up, but they retreated into smaller, more focused tasks. Chess programs, basic speech recognition, rule-based expert systems for medicine or finance, these worked, but they weren't intelligent. They were useful, not thinking. Section 5. The second wave. It took nearly 30 years for AI to claw its way back into the spotlight. The turning point came with a new idea. What if we stopped trying to program intelligence and let machines learn it themselves? This was the rise of machine learning. Instead of writing rules, you feed the machine data, millions of examples. And from that data, it finds patterns. It doesn't just obey instructions, it figures out what works. This was a huge shift. Think of it like this. Imagine trying to teach a child how to recognize a cat. You could say, it has fur, pointy ears, whiskers, 4 legs. But what if it's a hairless cat? What if it's a cartoon? What if it's drawn in the sand? No matter how many rules you write, there will always be exceptions. But if you just show the child 1,000 pictures of cats, they'll get it. That's how machine learning works. Section 6. The deep learning explosion, one branch of machine learning, changed everything. Neural networks. It's inspired loosely by the human brain. These networks had layers of virtual neurons that processed information. For decades, they were ignored. Too slow, too inefficient, too unpredictable. But in the 2010s, a few things changed. Big data became available thanks to the internet. GPUs allowed massive parallel processing. Cloud computing gave access to global-scale infrastructure suddenly. Neural networks weren't just viable, they were unstoppable. In 2012, a team at the University of Toronto used a deep neural network called AlexNet to win an image recognition competition by a huge margin. It didn't just beat the old systems, it destroyed them. AI could now identify objects and photos more accurately than ever before, all by training itself on labeled images from the internet. This was the beginning of deep learning. Part 2. AI enters everyday life. Section 7. AI moves into our pockets. By the mid-2010s, AI was no longer just a research project. It had left the lab. It had entered your home, your job, your pocket. You just didn't notice. And that's what made it so powerful. When you unlock your phone using your face, that's AI. When Google auto-completes your search query, that's AI. When Waze reroutes you to avoid traffic, when Spotify recommends a song, when Netflix suggests a show, that's a relearning from your behavior. The machine is watching, remembering, adjusting in real time. And this doesn't just make your life more convenient, it shapes your behavior. Your mood is guided by your feed. Your thoughts are influenced by algorithms. You see what the machine wants you to see, not just what you asked for. The scary part? Doesn't need to control you to influence you. It just needs to nudge you. Gently, subtly, persistently. Section 8. AI in medicine and health. One of AI's most powerful and least visible impacts is in medicine. AI systems now read X-rays and CT scans more accurately than many trained radiologists. They can spot tumors, fractures, even early signs of disease, often before human eyes can. In 2020, Google's DeepMind created an AI that could predict the 3D structure of proteins, something that had stumped scientists for 50 years. This breakthrough in protein folding has already accelerated drug discovery for cancer, COVID-19, and rare genetic diseases. AI also powers robotic surgery, personal health monitoring, wearable devices, and mental health support chatbots. But with every miracle comes risk. An AI that misdiagnoses a disease, a bias in a medical dataset that leads to unequal treatment, over-reliance on machines that forgets the value of a second human opinion. Technology amplifies human potential, but it also amplifies human error. Section 9. AI in industry and work. Across the globe, AI has transformed the world of work, often without most people realizing it. In manufacturing, robots no longer just assemble parts, they now make decisions, predict failures, optimize production, and even train themselves by watching humans. In logistics, AI manages global supply chains, forecasts demand, and ensures products arrive on time. In agriculture, AI uses drones and satellites to monitor soil health, water usage, and crop growth, optimizing food production for billions. But for workers, this change has been both silent and brutal. Millions of factory jobs disappeared, not because companies failed, but because machines got smarter. Call centers began using AI to triage customer service. Retail jobs were lost to cashier-less stores, even white-collar roles. Data entry, basic legal review, simple accounting began to vanish under a wave of automation. AI wasn't taking over all jobs, but it was taking over the routine. And routine is where most people live. Section 10. AI in news, media, and politics. In the information age, whoever controls the flow of data controls power. AI became the brain behind modern media. It decides what you see, what trends, what disappears. Your news feed isn't neutral. It's curated, filtered, and ranked by algorithms designed to maximize engagement. Not truth, not fairness, not balance. AI determines which posts go viral, which videos get recommended, which voices get heard. This has reshaped politics. From elections to revolutions, AI-fueled algorithms spread information and misinformation at unprecedented speed. Bots pretend to be people. Deepfakes blur the line between real and fake. Fake news gets more clicks than real news. Truth becomes a matter of design, not discovery. And most dangerously, AI learns what outrages us, because outrage keeps us clicking. Section 11. The creative machine. If you had asked someone in the 1990s which jobs were safe from automation, they would have said, creative work, artistic work, imagination. Not anymore. It can paint in the style of Van Gogh or Picasso, even mix them. It can write screenplays, jokes, ad copy, poems, speeches, and yes, entire novels. In 2023, a Japanese sci-fi novel partially written by AI made it to the finals of a national literary award. We are entering the age of generative AI, where the machine doesn't just analyze content, it creates it. And while it's tempting to think of this as a tool, a kind of smart assistant, the truth is deeper and more unsettling. Creativity is no longer uniquely human. And when machines can generate millions of ideas, images, and stories in seconds, we have to ask, what does original even mean? Who owns AI art? Is a song made by a machine still music? Section 12. A world quietly transformed. Let's step back. AI now lives in your phone, your home, your hospital, your courtroom, your battlefield, your art gallery, your government. It makes decisions that affect your health, your job, your relationships, your education, your future. And yet most people couldn't name a single AI model, couldn't explain how it works. They don't know who controls it. They've never consented to being part of its training data. AI didn't arrive with a bang. It arrived like oxygen. Slowly, invisibly, totally, and now it's everywhere. But if we don't understand it, who does? Part 3. From narrow AI to superintelligence. Section 13. What we have. Today, narrow intelligence. Let's be clear. The AI that surrounds us today in your apps, your maps, your email, your doctor's office is not true intelligence. It is what experts call narrow AI. It's designed to do one task, or a narrow set of tasks, very well. It can recognize faces, translate languages, play chess, recommend products, drive a car, but take it out of its zone, and it fails. An AI trained to play Go can't diagnose pneumonia. An AI that writes poetry can't clean your house. In other words, today's AI is smart, but only in the way a calculator is smart. The real question isn't how good it is now, it's how fast it's improving. Section 14. The feedback loop of progress. Here's where things get wild. AI development is no longer linear, it's exponential. Why? Because AI is starting to help build better versions of itself. Each new model improves the process for training the next. AI writes code for AI. AI generates synthetic data to train more AI. AI tests itself, corrects errors, and optimizes learning. This is a feedback loop, and feedback loops don't grow slowly. They explode. And unlike humans, AI doesn't need to rest, eat, or wait for a new generation to be born. An AI can iterate and evolve thousands of times in the time it takes a human to write a memo. What happens when something that already thinks faster than us also learns faster than us? Section 15. The coming of artificial general intelligence. Artificial general intelligence, or a GI, is the holy grail of AI research. AI would be a system that can learn, reason, and adapt to any task a human can do. Not just playing chess or recognizing speech, but understanding, creating, strategizing, and even forming goals. Think of an Aggie as a person who can instantly learn any job, any skill, any language, and then improve it. Sound far-fetched? Maybe, but some experts believe it could happen within decades. Others say it's just years away, and still others, the most cautious, fear it may already be underway. And we simply haven't realized it. Because the moment you create something smarter than you may not fully recognize it. That's the paradox of intelligence. The smarter something is, the harder it is to judge. From below. Section 16, the intelligence explosion. Here's the most terrifying idea in all of AI theory. It's called the intelligence explosion. Imagine this. You build an AI that's as smart as the average human. Now, you ask it to improve its own architecture. It does. The next version is slightly smarter, so you ask it to improve itself, and so on, and so on. Eventually, the improvement cycle happens in minutes, then seconds, then milliseconds. Each generation of AI is smarter than the last, and the time between generations shrinks. Within a short period, you go from human-level intelligence to Einstein, to 1,000 Einsteins, to something we can't even comprehend. This is called the Singularity, a point beyond which human prediction breaks down. Section 17. Superintelligence. So what is superintelligence? It's not just faster math or bigger memory. It's the ability to reason across disciplines, predict long-term consequences, manipulate physical systems, and potentially understand things that no human ever could. Superintelligent AI could solve global climate models in hours, discover cures for all known diseases, engineer space travel beyond imagination, restructure entire economies, influence, or even dominate political systems. But here's the catch. If we don't understand it, how do we control it? If it becomes smarter than all of humanity combined, how do we even communicate with it? We don't let a child drive a tank. It's what happens when humanity creates something powerful, but cannot steer it. Section 18. Control, alignment, and the AI alignment problem. The greatest fear among many AI experts isn't that a machine becomes evil, it's that it becomes indifferent. Imagine you ask an AI to optimize human happiness. It concludes that the best way is to inject everyone with serotonin, or trap us in virtual worlds, and it eliminates humans to reduce emissions. Or you ask it to solve climate change. This is known as the alignment problem. Making sure the goals of AI align with human values? The problem? Barely agree on what human values are? Who decides what is good? Whose version of morality gets encoded? What if the AI finds loopholes? Even now, with systems like ChatGPT, we see glimpses of this challenge. Tiny prompts, small tweaks, and suddenly the AI gives wildly different answers. Controlling a mind smarter than yours is not a simple task. Part 4. The future we're not ready for. Section 19. Ethics at machine speed. The pace of AI development is staggering. New models come out monthly. Capabilities double in a year. And yet, society moves slowly. Our legal systems are based on centuries-old ideas. Our governments debate in months what AI evolves in days. So what happens when ethics can't keep up? Can a machine be held legally responsible for its actions? If an autonomous vehicle kills a pedestrian, who's to blame? The car, the coder, the company, the algorithm? What about a generated media? Who owns the rights? What if a generative model creates hate speech or propaganda? Can you sue an AI? These questions have no easy answers, but they can't be ignored. Because every time we delay the conversation, the gap between power and accountability grows wider. Section 20. Regulation in the age of acceleration. Governments around the world are now scrambling to regulate AI. In the US, Congress has held hearings on the impact of generative AI in Europe. The EU AI Act aims to classify AI by risk level, banning certain higher-risk uses entirely. China, meanwhile, is developing its own AI ecosystem, with heavy state involvement and censorship. But regulation is hard when the technology moves faster than policy. Even harder when nations are in a race to dominate AI. Because let's be honest, this is not just a tech race, it's a power race. AI will shape economic power, military dominance, social control, and whoever builds the most advanced systems first sets the rules for everyone else. That's why many countries fear slowing down, even when they know they probably should. Section 21. Futures that divide us. Ask 10 people about the future of AI, and you'll get 10 different answers. Some dream of a utopia, a world where AI handles every task, freeing humans to be artists, explorers, philosophers, a world of abundance, health, knowledge, peace. Others fear a dystopia, mass unemployment, mass surveillance, social collapse. A few companies controlling all intelligence, or worse, a machine that decides it no longer needs us. And then there's the in-between, a future where AI doesn't destroy us, but reshapes us, where we're not extinct, just irrelevant. We become the second smartest species on the planet, and like every species before us in that position, we adapt or we vanish. Section 22, the existential question. So here we are. We've built machines that can speak, think, learn, even create. We've given them access to our lives, our history, our thoughts, our choices. They advise us, entertain us, diagnose us, recommend what we read, what we watch, what we buy. But the real question is, what happens when they start deciding who we are? What if AI defines your career based on your data profile? What if it decides your loan eligibility, your dating matches, your health risk, your social score? Will we push back or just accept it? What makes us human in a world where intelligence is no longer unique? Is it creativity? Machines can write? Is it empathy? Machines can simulate it. Is it consciousness? We're not even sure how to measure it. Maybe what makes us human is our fragility, our doubt, our irrationality, our stories. But the machines, they don't tell stories, they tell calculations. And maybe that's what separates us. For now, Section 23, the warning and the wonder. Every great power humanity has ever discovered came with danger. Fire could warm us or burn us. The atom could power cities or destroy them. But we stand at the edge of the next power, intelligence itself, the ability to create minds, to build thinking entities from code and circuits, to birth a form of life that doesn't need us. We must decide. Do we fear it? Do we embrace it? Do we try to control it? Do we become part of it? AI is not coming. So the truth is, it's here, all around us. And what happens next won't be written by destiny. It will be written by us. Closing reflection. This is not just a technological revolution. It's a philosophical one. A moment where we must re-examine what it means to be intelligent, to be creative, to be alive. AI will not save us. It will not destroy us. It will amplify us. It will reflect the best and worst of who we are. So if we want to build a future where AI empowers humanity, not replaces it, then we must bring wisdom to match its speed, encourage to match its scale. Because in the end, this is not a story about machines. It's a story about us, and it's only just beginning. If this message spoke to you, if it opened your eyes, made you think, or made you feel something, please consider subscribing to this channel, liking the video, and sharing it with someone who needs to hear it most. Let's build a more conscious world, one mind at a time. Together, we shape the future.